All right, so this is the second part of Pythagorean series, and we're going to apply the Pythagorean series to solve some problems. Okay. So let's record the Pythagorean series, the complete statement of Pythagorean theory. It says that a triangle is a right triangle if only a square plus b square equals c square, then the angle between a and b is a right angle. Okay, so this is origin. So that's actually two statements here, and this is a triangle, and here's a and b and c. So this angle, basically this angle is alpha. Okay, alpha equals 90 degrees if and only if a square plus b square equals c square. So that's the statement of the Pythagorean theory. And we do have several special right triangles. Special right triangles. I hope you memorize with the integer length. Okay, integer length says this is the special triangle is here is I think it's 2n, n square minus 1, n square plus 1. Okay. All right, so that's okay. So this is this gives you lots of special triangles. Okay, this formula. Okay, so in other words, n square minus 1 square plus 2n and square equals n square plus 1. So if you forgot some special right triangles, you just use this formula to figure out some of them. Okay. And that's so you memorize this one. For example, n equals 7, right? Then the 7 square is 49, and minus 1 is 48, and plus 2 times 7, 14, right? Then and that's a 50 squared because 49 plus 1. Then because all the numbers are even numbers, so you can divide by. Right, divide by 2, and then you get 25 squared. Okay. Okay, so this is a special triangle, and you can double check that. This is this gives you indeed like a 24 times 24 plus 49, right? Minus. Okay, so that's indeed a right triangle. Okay. All right, so now I'm going to apply the Pythagorean theory to solve some problems here, okay? Sometimes you have to draw addition lines to make a right triangle because you don't see the right triangle at the very beginning. But this problem is already told that this is a right triangle, okay? This is 90 degree here. And this right triangle, I know the perimeter is 220, okay? And the area is going to be 990 square units, okay? I want to find out the length of a hypotenuse, okay? Hypotenuse. Okay, so to solve this type of problems, we need introduce variables, right? Yeah, that is along the side. So this is a A, that's a B, that's a C. Basically, we want to find the C. Now you write down what you are given. Okay, given A plus B plus C equals 220. Okay. And the area is half of A times B, which is 990. Then you want to find out C. Okay. You can also find out maybe A and B. We don't know. That's my next question. Can you uniquely determine A and B if you already know the C? Okay. I think so. Okay. You find the A, B, C maybe, right? For all of them, okay? Okay, you can try to find A and B, C. Let's find the C first. Okay. So the best way to solve this problem is, remember, there's an important formula, we can always use it. A plus B squared equals A squared plus B squared plus 2AB. Okay, this is the important identity. And by the Pythagorean theory, this will be C squared, right? Right, by the Pythagorean theory, this will be C squared. So this is already given, right? 2AB is going to be 990, okay, times 2 times 2, because AB is going to be 990 times 2, then 2AB is multiplied by 2. So this is a fixed number. Now, how about A plus C, A plus B? A plus B is 220 minus C. Great, right? So you will get an equation in C only, okay, times 4, okay? So let's simplify. This actually is another quadratic equation. It's a linear equation after you simplify. Okay, after you simplify. Right, so you will get 220 squared minus 220 times 2. You know, it's actually 440, right? C and plus C squared, and this is a C squared plus 4 times 990. So C squared is gone. Okay, then you will see this C is here. So actually 440C equals 220 squared minus 4 times 990. Now, what is the best way to solve this problem? Well, they are all multiple of 11s. Okay, so here 4 times 11 times 10C, that'll be 2 times 11 times 10, right? And square, square, square. And here 4 times 9 times 11 times 10. So I think you can simplify this equation quicker. Okay, 4 and 2 square, 4 is gone. And 10, 10, 10 is gone. 11, 11, 11 is gone, right? So what you get is C equals 11 times 10 minus 9. So it's 101, okay? All right, so you get the value of C, 101. Now question is, how do you get A and B? A and B are not in equal position. You get 2 values for A and B. Then you will get similar results. Okay, let's go back to here. A plus B equals C is going to be 220 minus C. So 220 minus 101, right? That is going to be 119. That is A, right? And then A times B, 2AB is going to be, right? 2AB is going to be 990 times, I think, times 4, right? I think we're going to use, yeah, that's it. So from here, you can get A and B. Okay, that's 2 equations, 2AB. Now, the easiest way to do is to look at A minus B. You assume A is greater than B. Then you get, yeah, you get, if I have A, B, and then I can get an A plus, okay? So first, let's write down this. Plus 2AB, and then A minus B squared equals A squared plus B squared minus 2AB. So I take the difference of those 2, right? So I get A plus B squared minus A minus B squared equals 4AB. So now from here, A plus B, 119 squared. And this is A minus B squared, and then 4AB, okay? Wow, another 2 here. So 990 times 4 times 2. Okay. So finally, yeah, it's pretty complicated. So A minus B, yeah, A minus B is going to be A minus B is going to be square is going to be 119 square minus 990 times 4 times 2. Okay, so I think you can find A minus B from here. Then you take a square root, right? So if my computation is correct, okay, and then this is a 990 times 8, so total will be 641. Okay, so then you find A minus B. Okay, I'm not sure we are going to get the integers here. I know A plus B is 119, then A minus B, you assume A is greater than B. Okay, so then you will have, let's see, what is this? I don't have the scientific calculator. That should be perfect square, right? So A minus B is the square root of 6A minus square root of 6,241. Okay, now if you really want to make it a perfect square, 140 again. Yeah. So now you simplify this, then you get A plus B and minus B. You can quickly find A and B. Okay. So so let's see what is yeah, 6,241. I don't know whether it's a perfect square. It's not easy to see. Okay. But if you know A plus B, right, it's 119, and you know what is the value A and B. Okay. So you can quickly find A and B. Okay. If it's perfect square, then the last digit must be either 9 or 1, right, of that number. Okay, so anyone can have it's a 79. Yeah, great. So 79. Okay, so 79 times 79, double check, it's a 79. Great. I just guessed, right? So then from here, then you can find the A and the B, add them together. 2A equals 79 plus 119, right? It's 119, right? Yeah. Okay. So 79 plus 119, 108, 198. Then A is going to be 100. Yeah, 198 divided by 2. Yeah, it's going to be 99. Okay, great. Then B is going to be 119 minus 99, it's going to be 20. So it's a very special triangle here. You see, that's a 20, that's 99, 119. Okay, and this is a very special right triangle. Okay, great. All right, so our next problem. This time we need a draw addition lines. Okay, so the square, this is a 8 by 8 square. Okay, and there is a point here. This point P has the following property. The distance to the top line is the same as the distance to the both vertex. Okay, so this is A, B, and C. Here's a perpendicular. So PC equals PA equals PB. Okay, find this unknown distance PC. Okay, so question is, what is that? Okay, now when you look at this, no right triangle there. Now, how do you solve this problem? See the middle point on the top of line clearly, right? It's in the middle. Okay. The question is, how can you find this x? Okay. For the geometry, for the geometry problem, I think the most difficult part is to draw addition lines to find out the right triangle. So you can apply the Pythagorean theory. You are not given the right triangle like the one last time, the last problem, the previous problem. You are given the right triangle. Even that, you have to use the algebra, modify it, get the equation in C. Okay, then you can solve it. Here, I'm trying to get an equation for x. Okay, then I have to draw a addition line to find the right triangle. Right, find the right triangle. So where's the addition? Line? Where's the triangle? There are many triangles you can draw, like this one. And you can draw this one. Either way, it works. There are just so many right triangles. If you use this triangle, and this side is 4, but this side is 8 minus x. Okay, then this triangle is the right triangle. So applying the Pythagorean theory, then you get 4 squared plus 8 minus x squared equals x squared. Okay. Then you simplify, then you get x. As long as you get equation, then in x, then you solve the problem. So 16 plus 64 minus 16x plus x squared equals x squared. X is gone. Right? Okay, x squared is gone, then 16x equals 64 plus 16 is going to be 80, right? So x is 80 divided by 16. Okay, I think it is what, 5, right? It's a 5. So x is 5. Okay. X is a 5. Okay. Then you look at the picture. Is it reasonable? You double check that. Sometimes you get computation mistakes. Then you get a strange number. You get 15 for them instead of 5. Then it's obvious it's wrong. Look at the picture. X should be less than 8. Okay, and bigger than 4, right? All right. Our next problem will be the following. Okay, I have a rectangle. Okay, so here's A, B, C, and D. This is a rectangle. Okay, and I put point PE here so that what I got here is the right triangle. Okay, AED is the right triangle. ABC. Okay. Now, what we are given is the following information. EC, this is a 2. That will be 8. Okay. Okay, that's enough. So I want to find out the width of this rectangle. Okay. Now, can you try? Can you try? Okay. So, Michael, you have questions? I'm confused on that. All right. So I should pay more attention to my questions. Okay. So anyway, so take a look at this. Okay, a right triangle sitting in the rectangle, and right, so sitting in the rectangle, and E is a point on the top of length. Okay, DC, and I know One side is 8, other side is 2. Yeah, are you able to find the equation in X so that you can find the X? X cannot be arbitrary. Okay. Now the repeated conditions, here's a rectangle. I have a rectangle and I have a right triangle sitting there. Okay, the point E is the vertex or the right triangle. E touches the top side, DC. Okay, and so D equals 8, EC equals 2. Right. Kelvin, I have to mute you. Okay, make it noisy. Okay. So now I want to find the BC, which is the width of the rectangle. Okay. So the point is the idea is to apply the Pythagorean theory to a right triangle. And so you get an equation in X, then you solve for X. Right? Before you apply the Pythagorean theory, you have to express each side of the each side of the triangle. I can put it here, and okay, then put the A and here, B and here. Okay, you write all the possible identities. So how many right triangles there? 3. Okay. Now what is BC? What is AB? AB is 8 plus 2, which is 10. That's my hint. Okay. Because it's a right triangle. Because it's a rectangle, yes. So some of you get an answer here. Okay, Michael got an answer. Great. Anyone else? All right. You use a similarity. I'm not going to ask you to use a similarity. Okay, we use a Pythagorean theory. Okay, so we apply the Pythagorean theory to this triangle. Okay, and then you will get 2 squared plus x squared equals a squared. Okay, then you apply the Pythagorean theory to this side. Okay, then I got x squared plus 8 squared equals b squared, right? This is because this is also x. It's a rectangle. Then I apply the Pythagorean theory to this, okay, to this one in the middle. Then I get a squared plus b squared equals 10 squared, right? Because this side is 10. Okay. So now you have 3 equations, 3 unknowns. That's okay. 1 plus 2, I get 2 squared plus 2x squared plus a squared. And the right hand side is a squared plus b squared, right? And then this is going to be equal to 10 squared. This is by the third equation, right? So now you get the equation in x, okay? 4 plus 2x squared plus 64 is 100. Okay, and 2x squared equals 36. 36 minus 4 is 32. And x squared equals 16, and x equals 4. Okay, so this is yeah. Now you can use a similarity of the triangle. That's a great idea. You know, let's try this. Okay, it's 2, 8x. Okay, so this angle will be alpha, 90 degrees. If this angle is beta, then alpha plus beta equals 90 degrees. So this must be beta. Alpha plus beta plus 90 degrees is 180 degrees. So this must be alpha. So you have these two triangles similar. Okay, two triangles similar. This two triangles similar. Now, what is the corresponding side? And this side, let's use a color, same color. Okay, I'm going to use the same color for the corresponding side. So this side was this side, right? And this side, oh, I need a different color. This side was this side. Okay. So the ratio of the corresponding side, let's say 8 minus x should be x over 2, right? And even much quicker way to solve the problem. So x squared equals 16 and x equals 4. Great. I think this problem is might find out the method is a similarity, but this is a problem here. We're using Pythagorean theory. That's why I show you how to use the Pythagorean theory to solve the problem. But sometimes you can use a similarity of two triangles. All right, so now let's try another problem. Okay. Again, I have a rectangle. Then inside, I do have a right triangle. Okay, it's a right triangle. This is a rectangle. Okay. So what we are given? We are given this side is A, this side is B. I'll say A is a 4, B is a 5. No, that's typical, right? And the C equals 3, okay? Given this information, can you find out the area of the rectangle? So you already see a right triangle there, and you make a rectangle. So the question is, what is the area of the rectangle? Can you do that? Yeah, actually for an arbitrary right triangle, you can always draw a rectangle around that. Then you can find the area of the rectangle. Okay, because triangle is uniquely determined, then the rectangle is also uniquely determined. So you should be able to find the area of the rectangle, right? Then, if you really want to do something, and then I can draw an arbitrary triangle, then I draw a rectangle. Are you able to find the area of the rectangle? That is pretty. It's not necessarily a right triangle, right? You know, theoretically, you can say that the areas of the rectangle, yes, it is completely determined by the dimensions of the triangle. But the question, how do you express it, the relationship? Okay, so let's find out the area of the rectangle here. Anyone has answers? All right, anyone else? Can you post the answers here? Okay, what do you have to find out in order to find the area of the rectangle? Ask yourself, what data is missing? So you have to find out step by step, right? Okay, what is missing is this one. The width of the rectangle, right? The width of the rectangle is x. Okay, if you find x, you find the area. 5 times x is area. So the next step is you have to find the equation for x. Okay, do you have ideas? I give you half a minute to think about. Okay, time is up. So what is the area of the right triangle? The area of the right triangle is going to be 4 times 3 divided by 2 because it's right triangle. But on the other hand, x is the height of the right triangle, so you can use the base 5 times x, right? Right? That's the area of the right triangle. Now, clearly, x is going to be 12 over 5, right? So, Michael, when you get answer 12, you look at the picture. X should be smaller number, right? Because that's the width of the rectangle. Think about if x is 12, are you able to draw a right triangle so the one of the vertex that touch the top? Maybe not. So when you look at answer, you look at, okay, does it make sense? Okay, right? Obvious, right? So it cannot be 12. Yeah. Yes, it's okay. You do the computation, sometimes you make mistakes. You forgot. But when you get the answer, yeah, look at the answer and look at the picture. Okay, ask yourself, is this number reasonable? Okay, sometimes you can tell, okay, that it's obvious it's wrong. Okay, I think a 12 is very long, and one side, then you cannot make a triangle like that. Okay, yeah, the right triangle cannot be put there. Okay, good. All right, our next problem. Okay, so you have this is a square. Okay, let me call it square. This is a unit square. Unit square means each side has 1 unit. Okay, and this is A, B, C, D. Okay, E is the middle point. Okay, then F. Okay, F is a special number such that EF equals FC. Okay, so I'm going to find out the area of this triangle. Okay, find the area of the triangle EFC. Okay, please work on this. Now, you want to ask yourself, in order to find the area of triangle, what do you need to find out? You need to find out the height or something, right? There are many ways to solve this problem, but you need to find the base and the height. Okay. What's going on, Mike? Oh, I see. So now we're going to find the area. Look at this triangle, right? In order to find the area, there's a couple ways to solve the problem. If you are able to find the area as a small triangle, then you use a subtraction. You can find the area, right? So if you are able to find the area, there are a couple. If you are able to find the area of this triangle, then you can use a subtraction, right? The area of the larger triangle is already given, right? And then for this triangle, small one, what are you gonna do? You have to find out BF, right? But I don't know what is BF, right? So you have to find out FC, doesn't matter. Okay, let's call the FC is X, right? And this side equal, that's X. So if you're able to define X, you're able to find the area. Okay. Why? Because area of the triangle EFC is going to be half of the base. The base is X, right? The height is 1/2 because it's a E is the middle point, right? The base times height. But you can also use the area of the triangle EBC, right? Minus the area of the triangle the small triangle EBF. That's fine. So then EBC is going to be half of, right? 1/2 times 1, right? This is the area. It's a larger triangle minus the area small triangle. This is base, and the height is BF. BF is 1 minus X. So after you simplify it, you still get X over 4. So basically just to find the 4 anyway. Okay, so same. So you find X, okay? Find X. You need find the right triangle and apply the Pythagorean theory to the right triangle. Okay. So what is a BF? BF is 1 minus X. What is EB? EB is 1/2, right? So now you can apply the Pythagorean theory to this little triangle, okay? To this little triangle, EBF. Here's 1 minus X, this is X, this is 1/2. Okay, so now 1/2 square plus 1 minus X squared equals X squared. Okay, let's try to simplify it. 1/4 plus 1 minus 2X plus X equals X squared. X squared is gone. And 2X equals 1/4 plus 1, which is 5 over 4. And X is 5 over 8. 5/8. Okay, then once you get x, then you can get the area. The area is going to be quarter times x, 5/32. All right. All right, so now we have a next problem. So I have a right triangle again, and this side is A, this side is B. And I draw the line perpendicular to BC. Okay. So my question is, can you express BD and DC in terms of AB? Okay. So I call the X, I call the Y. Okay, now sometimes we are given a very specific number, right? So how do we solve this problem in terms of X and Y? Express, if we can get, I think the main point is just get H, okay? So if you're able to express H in terms of AB, then you solve the problem, okay? So how do I do that? Well, right, X is gonna be, you know, X squared plus H squared equals A squared, right? So X is going to be square root of A squared minus H squared, right? You move X squared to the right-hand side. So basically you have to find the H. Is there any better way you can find the H? The height of the triangle. Okay, the technique we use that to find the area. The area of the triangle ABC is going to be half of A times B, right? That's one formula. But you can also use that. It's going to be half of the base. Base is BC, right? BC actually is going to be, yeah, if this side is a C, that's a BCH, right? So, but we know that C's can be expressed A plus A and B. So H is going to be A times B over C. Okay. Okay. Now what is H? H is a square root of A squared plus B squared. So you find H, then you can find the X. Okay. So let's find X. All right. So that's it. This is the formula. You can simplify it. Yeah, after you simplify, you can get nice formula. Okay. So this is how do we derive the formulas. You know, we don't deal with the specific numbers. Okay. And if you know, you may get given a specific example. You know, this is right triangle. Here's 3. Here's a 4, and I draw the line. And what is the X here? What is the Y here? Right. Now, once you get formula, you can just plug the numbers in the formula. Otherwise, you have to do it by yourself, step by step, dealing with the specific numbers, right? So this side is a 5 by the Pythagorean theory, and then you use a area formula, right? The area is going to be half of 3 times 4, right? And this is h, and it is also half of 5 times h. So h is going to be 12 over 5. Okay. Then use the h, you can get x. Okay. X is going to be 4 squared minus h squared. It's 12 over 5 squared. All right. Then you simplify. All right. That's a two-step of problems. All right. I'm going to ask you to do the next problem. This is a rectangle. Okay. So I'm better to put the specific numbers here. So this is a rectangle. Okay, and what I'm going to do is this is a B, C, D. Okay. So I got point here, E. I folded this to this side, F. Okay. So this, yeah, just fold it, you know, then B touches F. This is a point. So these two triangles are congruent, right? Because you folded it along this line. Okay, we are given the information. If this side is a 3, this side is a 4. Can you determine the dimension of the rectangle? Find the AB and AD. Okay, so you have a piece of paper, rectangle paper, right? You choose a point E. When you fold it along this line, you see, then there's one side of the triangle, now it's on the other side, and B touches the edge of the rectangle. Okay, so quickly you can see that EF is going to be 5, right? Because it's a right triangle, so it's 5. Right? So can we find out? Can we find out what? Can we find out this side is X, Y? This side is X. We have to find X and Y. I think it can quickly get X. Okay. Yeah, step 1, you find X. My hint is X consists of this part and this part. Okay. But this part is equal to that part. Can you see that? Because these two triangles are congruent. Okay. Okay, let's finish this problem. So clearly, right, x is going to be, you can see that, right? X is going to be 3 plus 5, which is 8. Now, the question is, how can I get a y? Okay, so you have to apply the Pythagorean theory to sum of triangles. I think if this side is y, this side is by, right? Because it's two triangles congruent. And this side will be y minus 4. Great. So now we apply the Pythagorean theory to this triangle. Okay, to this triangle. Because each side already expressed in terms of y, okay? Yeah, so it is going to be, okay, y minus 4 square plus x square, x is square, 8 square equals y square. So once you get this equation, then you can solve for y. All right, so y is going to be 8y is going to be 16 plus 64, and it's 80. So y is going to be 80 divided by 8, which is 10. Oh, it's not 12, it's 10. Come on. Okay, Mike. I think it's 10. All right? Yeah, it's 10. All right, so let's do a similar problems. This is a square, not a rectangle. Square, be careful, square. Then I draw the line. So this is a right triangle, put in this form, EFC, okay, ABCD. Okay, and this side is 3, and this side is 4. Okay, yeah, for this little triangle you get 3 and 4. Now, can we find the area of the square? All right, find the area of the square. Okay. So how to find the area of the square? You have to find the x, right? X, that's x. Then your x squared is going to be. The question is how do you find x? Right, you have to apply, you have to use the assumption. This x, this triangle is a right triangle. This is a right triangle. Okay. So this side is 5, it's already given. This is C, and maybe I call it A, right? So somehow we have to use this one as a right triangle. So A squared plus 5 squared equals C squared. Yeah, write all the equations you can get from by the Pythagorean theory. Okay. Now how about this triangle? This is also right triangle, right? Oops. This is also right triangle. Okay. So apply the Pythagorean theory to this triangle. I think I have an x squared plus other side is actually x minus 3 and equals c squared. Okay, good. Then I apply the Pythagorean theory to this triangle. Okay. Then what? And I think you will get x squared plus x minus 4 squared equals a squared. Okay. Now you look at how many unknowns? You have a, c, and x. You have 3 equations, 3 unknowns. You are able to solve it. Okay. So in the place of a squared, I replace by this. In place of c squared, I clear that. So what I'm going to get here is x squared, x minus 4 squared, and plus 5 squared equals c squared, x squared plus x minus 3 squared. Okay. Simplify. And you're not going to get a linear equation. Actually, you're going to get equations. Linear. Yeah, no, it's not a quadratic equation, it's linear equation. So we have x squared minus 8x plus 16. Here's 25. And here's x squared minus 6x minus 9. X squared is gone. Okay. Yeah, well, then we solve this equation. We move 8 to this side, right? And 9 to the other side. 16 plus 25 minus 9 is going to be 8x minus 6x. It's a 2x. So this will be 16, right? So 2 times 16. So x should be equal to 16. That's correct answer. Double check, if does this sounds reasonable? I think so. 16. Okay. All right, I think that's all we can discuss today. So as you can see that sometimes you not only just name the variable for the age of the square, and there are lots of unknown variables here involved, right? A and C. And you just write down, express each side in terms of A, B, C, whatever in the variable you can introduce. Then you apply the Pythagorean theory to each right triangle. And you write down all the equations, then you see, I can quickly get equation in X. Okay. This A replaced by this A, this C replaced by this C, you get equation in X. Then you solve it. Okay. So sometimes you have to draw addition lines. And so we are going to study that when we're going to also use the Pythagorean theory to solve other problems later when we study circles and the relationship with the triangles. For this one, yeah, you don't need to draw addition lines, but you have to apply Pythagorean theory to each of the right triangle you can see. Then you can solve the problem. Okay. It's great. So sometimes you apply the Pythagorean theory twice or 3 times at the same time to different triangles. Right. Then you solve the problem. All right, so let's stop here.